All right, so we're looking at how to find the present value of a stream of cash flows. These cash flows, this is money that we're expecting in the future. And what we are trying to do here is to find the present values, how much these amounts of money are worth today. All right, so basically, we're going to use this formula present value equals the future value 1 plus R, which is the rate, can be the interest rate. All right, close the brackets to the power negative t. All right, this t will represent the year in this case, each year. So let me just copy and paste. Right, so the question reads, what is the present value at the end of the fifth year of the following stream of cash flows received at the end of each of the 5 years if each is invested at a rate of 15%? Right, so we come here, solution. So our rate, which is R, is 15%. So we convert that into a decimal. So 15% into a decimal and equal to, say, R equals 15%. That equals to 0.15. Right? Now, this is where we can use that table which I showed you, all right, because it is going to make life very easy, okay? The manual way of doing this, all right, let me just show you the manual way, then I'll also show you how we do it with the table. The manual way of doing this is we're going to add up all these present values, all these future values. Each of them will convert them to a into a present value, then we total them up because we just want to find the total present value of these cash flows. So what you're going to do is present value equals, so we're going to start year one, we're going to say 300. This is our future value. So the 300 is substituted here with this future value. Open brackets, 1 plus 0.15, the power negative 1, plus 9. The second cash flow is this 200. So I'm going to say 200, open brackets, 1 plus 0.15, power negative 2, plus 150, open brackets, 1 plus 0.15, power negative 3, plus 100, 100 plus 100, open brackets, 1 plus 0.15 to the power negative 4, plus 200, 1 plus 0.15 to the power negative 5, right? So before I proceed further, are we okay, colleagues, with what is happening here? Are we following with what's happening here? These future values, we're converting them individually into present values using this formula here. Do we have any queries before we go further? All right, wonderful, wonderful, wonderful. All right, so now this is where the table comes in. Let me just get this table here. Let me bring it nearby. The present value table. All right, so this present value table is going to give us the individual discount factors. All right, instead of you using a calculator to tabulate these 1 plus 0.15 to the power negative 1, 1 plus 0.15 to the power negative 2. Instead of using your calculators, you can just go straight to the table, all right, to acquire these discount factors. So on our table, our rate is 15%. So we come to the table here. Okay, the rate is 15%. All right. So you come year one, the discount factor is 0.870. Right. Year two, the discount factor is 0.756. Let me just highlight where I'm reading from. Oops. Yes. This is where I'm reading from. Year one, discount factor 0.870. Year two, 0.756. Year three, 0.658. Year four, 0.572. Year five, 0.497. All right. So you can confirm those in the calculator. Like, for example, in your calculator, just type in 1.15 to the power negative 1. Tell me what value you get. 1.15 to the power negative 1. Tell me what value you get. And compare it here on the table. In your calculator, 1.15 to the power negative 1, you should get 8.70. 8.870. Has someone confirmed? And as you are confirming. So 1.15 to the power negative 1. Oh, yeah. So that's 0.869. You can round it off to 0.870. All right. You'll get figures close to this. So you can round that off to 0.870. Okay. Or you can use that same value. Okay. But if you're using this table, you just have to equate it to 0.870. All right. So here we can write equals 300 times 0.870, right, plus 200 times, so 1.15 to the power negative 2, you should get 0.756 or a number close such that when you round off that number, you get 0.756. All right. So here we put times 0.756 plus 150 times 1.15 to the power negative 3. You come to year 3, all right, 0.658 plus 100 times, so 1.15 to the power negative 4. You come to year 4, under 15%, 0.572, right? Your calculator won't give you these exact values, but when you round off, you get these values. 0.572 plus 200 times 1.15 to the power negative 5, 0.497. Okay, before we move further, colleagues, are we okay? Are we comfortable? Are we all following? Oh, we're doing it according to the years, all right? As you can see, year 1, year 2, year 3, year 4. That's why the powers are going from -1, -2, -3, -4. So that's, we're following them in, I can say, chronological order. Yeah. Okay, so 300 times 0.807. 100 times 0.8, you get 261. So what this is saying is this 300 kwacha you're expecting in the future in year 1, its value is 261 kwacha, right? This 300 kwacha, its value today is 261 kwacha. Plus, so 200 times 0.756, you get 151.2. So yes, this 200 kwacha, which we're expecting in year 2, today its value is 151.2. 150 times 0.658 times 0.6, all right, 98.7. Right, this 150 kwacha, which we expect in year 3, its value today is 98.7 kwacha. Then 100 times 0.572, just count 2 decimal places, 1, 2, so 57.2. As 200 times 0.497, okay, 99.4. All right. So what we've done here, all these filter values, we've got their values at present, at now. All right. So let's just tabulate the total. So we say 261 plus 151.2 plus 98.7 plus 57.2 plus 99.4. All right. So the total present value is 667.5 kwacha.